Hello friends, I am Equivalence. I am going to talk about equivalence partitioning and boundary value analysis. Part 1. Equivalence partitioning. What is equivalence partitioning? Let me explain what do you mean by the equivalence partitioning. Equivalence partitioning is a method for deriving test cases. In this method, we will be going to identify such those who are having the same kind of processing, and it will represent that partition. So we can say that equivalence partitioning divides large set of value into partitions. It expected to behave same for all the values in the equivalence partitioning. Dear friends, please note, it is very important that whatever the partition we will be going to have, that partition values should behave in the same manner. So we can say that out of 20 values, if I tested 2 or 3 values, so and whatever the result, whether it is valid or invalid, it will be applied to rest of the values. So that's what, when you are partitioning, you have to check it whether all the values in that equivalence partition is behaving in the similar manner or not. Each test is representative of that partition. Sometimes it may happen that equivalence partition not found in the domain. Let me talk about benefits of equivalence partitioning. This is a very amazing technique which helps us to reduce the total number of test cases to a finite set of testable test cases, still covering maximum requirements. In short, it is the process of docking all possible test cases and placing them into classes. One test value is picked from each class while testing. So it will reduce the number of test cases as well as it will reduce the time which we need for testing. Let me give the one example. In our academic, we are generating the grade sheet. BSc IT grade sheet with percentage of subject is as given below. Here we are having the grades O, A, B, C, D, E, F, and there they are mapping with the percentage. If the percentage are 70 and above, so students will award it with the grade O. If it is in between 65 to 69, student will award it with grade A, and so on. So I may be going to take only one value which is 70 and above. So if I say the 75 and it is giving me the result O grade, so this means this will be true for all the values which is in between 70 and above. So this is what I can say that the way to generate the test cases for the equivalence partitioning. Equivalence partitioning, which will be possible to go with the certain more examples. So here I am having one more example, simple example. I am going to test the values from 1 to 1000. So how I will be going to test these 1 to 1000 values? Am I going to test each and every value so that I will be having the 1000 valid input test cases, or I will be going to have the partition, equivalence partitioning, so that it will be reduce the test cases? So here I am supposed to test the valid input numbers as well as invalid input numbers, so that I will be going to assure that it is not accepting invalid data and it is accepting the valid data which is giving the same type of output. Using equivalence partitioning method, test cases can be divided into 3 sets of the input data called as classes. So I can say that if we are having the particular large set, so that broadly that test case which you can divide into broadly into the 3 test cases. So test cases, testing process for equivalence partitioning. that can be the 1. We can say that the number 1, which we can have one input data class with all valid inputs. Pick a single value from 1 to 1000 as a valid test case. So I will be going to check only one test case in between the valid test cases. If you select other values between 1 and 1000, then result is going to be same. So one test case is valid input data should be sufficient. So you just imagine when I'm supposed to check the 1000 values, but I'm right now going to check only one value as a input data. So, and the second, I would like to also check the invalid data. So I would be like to have the one is for the lower limit and the another for the upper limit. So you can see that here input data class with all values below lower limit, that is any value below 1 as invalid input data test case. Input data with any value greater than 1000 to represent the third invalid input. So you can say that broadly we can have the 3 cases which is in between the class. I can say the valid class and the another one is the below the lower limit, and the another one is the upper I can say that the upper limit. So these are the test cases which we can generate for the equivalence partitioning. Let me explain one of the examples. Here there is a multiple choice question. Given the following specification, which of the following value for age are in the same equivalence partitioning? If you are less than 18, you are too young to be insured. Between 18 to 30 inclusive, you will be receive the 20% discount. And the third condition, anyone over 30 is not eligible for discount. Now you can observe these choices: 17, 18, 19, 29, 30, 31, 18, 29, 30, 17, 29 and 31. So you can see, before going to find out the answer, we will just design the test cases. This can be the class 1, class 2, class 3, or I can say the test cases 1, condition 1, condition 2, condition 3. So first is that age is less than 18, they will be not insured, whereas class 2, that will be the in between 18 to 13 age group, they will be getting the 20% discount, and the age greater than 30, then there will be no discount. Now I would like to see that which are the input values which are coming from the same class. So you can see that 17, 18, 19. 17, 18, 19. Here 17 is below 18, whereas 19 is above 18. So this will not be from the same class. Whereas 29, 30, 31. Again the 30 in between 29 and 31. 29 is below the limit, whereas 31 is upper the limit, and 30 is in the limit. So again this will not be from the same class, whereas we can say that here 18, 29 and 30, which you can observe over here that 18, 29, 30, which is falling in the same group. So 17, 29, 31, this is also the invalid, or we can say that it is not coming into the same group, whereas 18, 29, 30 are coming in the same group. So I can say that ultimately the answer is C. So you can see that here we cannot determine if the above class are valid or invalid, but yes, we can find out that which are the option is coming into the same class group. So answer is C for this particular multi-choice question. And yes, now we will be going to start with the another part of this particular session, that is part 2, boundary value analysis, and this will be